In the abyss of the cosmos, there's a sentinel that whispers tales of the great beyond. The Voyager 2 spacecraft. A testament to human audacity and technological prowess, this vessel sails through the treacherous oceans of interstellar space. Launched over 40 years ago, this resilient explorer defies every limitation set by man and machinery, venturing into realms where no machine crafted by human hands has ever reached. In its voyage beyond the fringes of our celestial neighborhood, it has relayed startling discoveries, painting a canvas of our universe that, until now, was unimaginable. Imagine the shivers that ran down the spines of mission controllers on Earth when Voyager 2 relayed a haunting discovery, a gargantuan wall of fire at the very threshold of our solar system. This boundary, this ethereal wall of flames, holds secrets that can reshape our understanding of the cosmos, and perhaps even our place within it. But what transpires at this mysterious frontier? And more chillingly, what repercussions could it have for our very existence? Yet, what keeps this sentinel alive and communicating in an environment so indifferent, so chillingly hostile? Is it magic? No, it's sheer engineering brilliance. While its multitude of sensors and transmitters play a crucial role, they would be rendered mute without their lifeblood, power. Unlike what one might assume, these pioneers, Voyager 1 and 2, are not sustained by the sun's rays, for the sun's embrace grows dim in the abyss they traverse. Their heartbeat is, in fact, powered by radioisotope thermoelectric generators, RTGs. Using the decay of plutonium-238, these marvels of engineering convert emitted heat into electricity. However, like all things, even these generators aren't immune to the ravages of time. Their power wanes, with their once robust 470 watts at launch dwindling to a mere 270 watts by 2011. But the Voyager 2, it seems, came prepared for the long haul. Nestled within it is another marvel, thrusters that allow it to reorient and face its creators back on Earth. These thrusters sip from a precious reservoir of hydrazine fuel. In a breathtaking revelation, after nearly 4 decades of dependency on the main thrusters, NASA was compelled to awaken its dormant backup thrusters. Lying in stasis for 40 years, they roared to life, continuing the spacecraft's monumental journey. Delving deeper into the cosmic darkness, Voyager 2 unveiled its most staggering achievement. Becoming only the second craft to touch the realm of interstellar space, it drifted 119 times farther than the distance separating Earth from our Sun. While its sibling, Voyager 1, may have treaded this path before, it was Voyager 2 that sampled the intoxicating elixirs of interstellar space, electrically charged hazes, and the elusive plasmas at the fringes of our solar dominion. As it danced between stars, Voyager 2 studied the ballet of solar winds, unraveled the mysteries of plasma particles, decoded the cosmic rays' stories, and sketched the magnetic fields shaping our universe's tapestry. This invaluable data continues to quench the thirst of scientists back home, challenging and affirming theories alike. But to truly grasp the monumental revelations of Voyager 2, one must re-examine a fundamental celestial giant, the Sun. Far from a silent guardian, it rages and roars, and its secrets intertwine deeply with the tales Voyager 2 whispers back to us. Amidst the inky vastness of space, our Sun is not the tranquil beacon we might envision from our blue-green world. It is, in reality, a tempestuous nuclear cauldron, blazing its trail across the galaxy at a staggering speed of 450,000 miles per hour. Orbiting the galactic nucleus, it moves with an urgency, a fervor that belies its serene appearance. We, on our planet, remain blissfully unaware of its frantic dance, shielded by the vast expanse of our solar system. But there's more to the Sun than just its heat and speed. It continuously erupts, birthing magnetic maelstroms that churn out a cosmic wind of charged particles known as the solar wind. This celestial gale spreads outwards in a symphony of chaos, carrying the Sun's magnetic imprint with it. It eventually collides with the interstellar medium, remnants of long-dead stars, an ethereal graveyard that lingers between stars. Like two mighty forces locked in an eternal dance, they resist blending entirely. Thus, the solar wind forms a protective cocoon in the interstellar medium, christened the heliosphere by those who study the stars. This monumental shield, spanning a breathtaking 11 billion miles from the Sun, encompasses all that we know: the Sun, the 8 planetary dancers, and countless celestial objects twirling in their orbits. But this heliosphere isn't just a cosmic boundary. It's a guardian. It shields every particle, every life form within its embrace from the galaxy's most lethal radiation. Without its benevolent protection, the very code of life, our DNA, would be in peril. Yet, every guardian has its limits. The heliosphere's frontier, termed the heliopause, marks the beginning of true interstellar space. How does this boundary appear, one might wonder? Understanding this could provide unprecedented insight into our Sun's celestial dance and shed light on the fates of countless other stars in the cosmos. As Voyager 2 approached this edge, anticipation gripped the scientific community. Its sibling, Voyager 1, had experienced instrument failures during its crossing, leaving the transition shrouded in mystery. But Voyager 2's journey was illuminated. Drawing near to the heliopause, researchers witnessed a cosmic spectacle. The plasma enveloping the spacecraft transformed, slowing down, growing denser and heating up, akin to a celestial beast awakening from slumber. But as Voyager 2 emerged on the other side, the temperatures soared to a blistering 54,000 degrees Fahrenheit, far beyond what any had predicted. Yet, against this inferno, Voyager 2 persisted, protected by the diffuse nature of the plasma that kept its immediate surroundings chillingly cold. Voyager 2's odyssey unraveled more enigmas. The heliopause wasn't the impenetrable fortress many had envisioned. Instead, it was a porous boundary, allowing particles to traverse both ways. It revealed tendrils of interstellar matter that penetrated the heliosphere, reminiscent of tree roots breaking through rocky ground. As Voyager 2 ventured further, it painted a picture of a bizarre liminal realm, a layer where the solar wind's momentum faded before encountering another layer, mystifyingly similar to one observed by Voyager 1. But the revelations didn't stop there. The Sun's influence, it seems, transcends our solar system's boundaries. Coronal mass ejections, CMAs, mighty waves of plasma hurled by the Sun, sculpt our solar domain. Voyager 2's data divulged how these CMAs journey beyond the heliopause, affecting cosmic rays in the interstellar medium. In a cosmic ballet, supernovas too send shockwaves throughout the galaxy, although with a gentler touch than CMAs. It's humbling to consider that even our very solar system's birth was ignited by a supernova's ethereal call. Venturing beyond our planetary borders allows us not only to delve deep into the mysteries of our solar system, but to also seek understanding about the larger cosmic patterns that influence the dance of life on Earth and potentially on distant alien worlds. Voyager 2's revelations hint at the Sun's profound influence on potential extraterrestrial evolutionary pathways. This understanding beckons us to reevaluate the interconnectedness of our Sun, our home, and distant starlit realms. Unlocking the mysteries of the interstellar domain, however, demands a comprehensive understanding of the heliosphere. As Voyager 1 made its audacious exit near the heliosphere's vanguard, where it meets the interstellar medium in a cosmic clash, Voyager 2 made its mark by venturing out along its side. Yet, much remains elusive. The heliosphere's trailing end is still an enigma, cloaked in cosmic uncertainty. Could it be a near-perfect sphere, held in shape by the relentless push of the interstellar medium? Or might it possess the whimsical tail of a comet, or perhaps the curves reminiscent of a delicate croissant? It's essential to remember that the Voyagers are not lone rangers in the vast sea of space. Many other celestial emissaries embark on their own journeys, but the catch is their inevitable exit from the solar system, leaving us with tantalizing mysteries, their tales unfinished. Voyager's longevity and continued data transmission are, in part, due to its ingeniously designed power source. The spacecraft's house radioisotope thermoelectric generators, RTGs, a marvel of simplicity and nuclear prowess. Within these generators, a radioactive core of plutonium-238 sits ensconced, releasing alpha particles that, in their decay, create a temperature differential. This differential, when contrasted with the cold vastness of space, results in electricity generation. However, as with all things finite, plutonium-238 decays. With a half-life of 87.7 years, its energy wanes over time. By the close of the 20th century, after 23 years of tireless service, the Voyagers' RTGs were generating merely 67% of their launch energy. Yet even with this diminution, their contributions have been monumental. Cast your mind back to April 24, 1979. The world watched with bated breath as Voyager 2 relayed its first images of Jupiter. These weren't mere snapshots, but cinematic chronicles of atmospheric dynamics. Unlike Voyager 1, its sibling took bold dives, getting intimately close to Jupiter's moons. With a particular focus on Europa and Io, Voyager 2 beamed back images that redefined our understanding of the Jovian system. This cosmic envoy managed to get as close as 127,830 miles from Europa, offering unparalleled views. At its nearest, the spacecraft was a mere 400,785 miles from Jupiter, showering us with data on its cloud systems, newly identified moons, a mysterious ring system, and a staggering 17,000 images. Recalling the Pioneer spacecraft's rendezvous with Jupiter, they had noted minor atmospheric shifts. In contrast, Voyager 2 detected drastic transformations. The Great Red Spot, that iconic Jovian storm, wasn't just drifting, it was morphing, changing in both hue and form. Thanks to the joint efforts of the two Voyagers, we've mapped vast swathes of Ganymede and Callisto with incredible detail. After its momentous rendezvous with Jupiter, Voyager 2 adjusted its trajectory, now with its sights set on Saturn. But the celestial narrative didn't end there. A pivotal decision in January 1981 charted a new course for this brave explorer, onward to the distant realms of Uranus and Neptune. Voyager 2's expeditionary saga continued, painting the canvas of the 1980s with otherworldly discoveries. By August 1981, the spacecraft was poised for its rendezvous with Saturn, the ringed giant. Merely 2 years had elapsed since it bid adieu to Jupiter's magnetosphere, and it had already covered the vast distance to Saturn. The satellite moon Iapetus was its initial focus, and Voyager 2, in an echoing choreography, retraced its predecessor's photographic footprints. However, it dared to venture closer, approaching within a mere 14,290 miles of Saturn, offering us unparalleled vistas. The mysteries of Saturn's rings were further unveiled, revealing intricate spokes, unexpected kinks, and the beguiling F-ring, all previously hinted at by Voyager 1. The data conveyed that Saturn's A-ring might be astonishingly thin, with a speculated thickness of about 980 feet. But this journey wasn't without its perils. As Voyager 2 danced past Saturn, it sliced through the plane of its illustrious rings at a breathtaking speed. During this daring maneuver, countless micron-sized dust grains collided with the spacecraft, vaporizing upon impact and producing a spectral display of puff plasma. Then, another hurdle appeared. The scan platform malfunctioned. As we gazed upon departing images of Saturn, engineers and scientists back home pondered over potential fixes. Despite these hiccups and the countless automatic adjustments the spacecraft made to stabilize itself, Voyager 2 persisted, capturing immaculate images of Saturn's satellites, including Enceladus, Tethys, and the more obscure Phoebe, Helene, Callisto, and Calypso. But rest was not on the agenda for this industrious explorer. Uranus beckoned. The course set for Voyager 2 ensured that it could potentially journey beyond Uranus to Neptune. Its celestial ballet with Jupiter had been orchestrated, in part, to ensure these distant planetary encounters were within reach. Making history yet again, Voyager 2 became the inaugural human-made object to venture past the verdant giant, Uranus. The distances now were mind-boggling. Communication signals, traversing the void at light speed, took a staggering 2.5 hours to bridge the gulf between Earth and the spacecraft. Amidst the dim light, equivalent to only a fraction of terrestrial brightness, Voyager 2's proximity to Uranus brought forth 10 previously unknown moons, christened with names plucked from Shakespearean lore. Puck, Portia, Juliet, and so on. But moons weren't the only revelation. The spacecraft identified 2 additional rings, augmenting the known 9, and uncovered a perplexing magnetic field, misaligned and off-center. The enigmatic winds of Uranus, surging at speeds of up to 450 miles per hour, whispered tales of a tumultuous, boiling ocean beneath its cloud canopy. The moons Miranda, Oberon, Ariel, Umbriel, and Titania were immortalized in detailed images. As Uranus faded into the distance, Neptune, the blue behemoth, loomed large. Closing in on 4.3 billion miles from Earth, Voyager 2 soared a mere 2,918 miles above Neptune's cloud ceiling, becoming the pioneering human artifact to grace its vicinity. The Neptunian realm divulged its secrets: 6 fresh moons and 4 ethereal rings. The icy expanse of Triton, Neptune's largest moon, laid bare its frigid heart, marking the coldest planetary body we've known. And in a twist, an active nitrogen ice volcano was spotted on its surface. Thus, after an epic journey spanning 12 years in the vast abyss, Voyager 2 concluded its grand planetary tour, a monumental feat that, for a time, made the cosmos feel a tad smaller and far more wondrous. Post its intimate rendezvous with Neptune, Voyager 2 continued its unrelenting journey towards the unknown, charting a path beneath the ecliptic plane, departing from the gravitational embrace of our solar system. Around 35 million miles after its encounter with Neptune, a calculated decision was made to transition its instruments into a low-power mode. This strategic choice was vital to prolong the spacecraft's operational life, allowing it to continue relaying precious data back to Earth. In recognition of the spacecraft's shift towards the vast interstellar void, NASA rechristened the project as the Voyager Interstellar Mission, VIM. This designation signified the spacecraft's pioneering voyage beyond the confines of our home system. As a testament to the incredible foresight of 1970s engineering, 3 spacecraft from that era, Voyager 1, Voyager 2, and Pioneer 11, were all aligned towards the solar apex, charting the apparent trajectory of the Sun within the Milky Way. This alignment suggested they would likely penetrate the heliopause earlier than Pioneer 10, which was navigating towards the heliospheric tail. In a bid to extend the operational duration of the spacecraft, non-essential instruments aboard Voyager 2 were deactivated in November 1998, a whole 21 years post its launch. Despite these adaptations, NASA's Jet Propulsion Laboratory, JPL, persistently received valuable data. A significant cosmic event in January 2001 stands out: a colossal shockwave emanating from the heliosphere's periphery in July 2000 engaged Voyager 2. This shockwave, having traversed the solar wind, accumulated and accelerated charged particles, blessing scientists with an invaluable cache of data from the high-energy shock-energized ion. By August 2007, Voyager 2 had reached a landmark position, navigating through the termination shock and subsequently entering the heliosheath. Fast forward a decade to November 2017, and the spacecraft was an astounding 116.167 AU from our blue planet, rocketing through space at a staggering 9.6 miles per second relative to our Sun, charting a path towards the constellation Telescopium. In a momentous event on November 5, 2018, Voyager 2 breached the heliopause, the realm where the Sun's dominion ceases, launching itself into the interstellar medium. While its sibling, Voyager 1, had navigated this boundary earlier, the occasion wasn't without disputes. Yet Voyager 2's instruments registered irrefutable evidence of its transition, a significant surge in particle density, accompanied by temperatures ranging between 30,000 to 50,000 Kelvin. Revisiting its roots in July 2019, Voyager 2 ingeniously reactivated its trajectory correction maneuver thrusters, a system that had been dormant since its Neptune encounter in 1989. The need arose due to the deteriorating performance of its attitude control thrusters. Voyager 1 had undergone a similar shift in its propulsion system in January 2018. To keep these timeless Voyagers transmitting invaluable interstellar data, mission engineers on Earth had to draft innovative strategies, often facing tough decisions regarding which instruments to retain and which thrusters to deploy. Voyager 2's journey is emblematic of humanity's insatiable curiosity, even as it drifts billions of miles away. With its signals taking over 17 hours to reach home, this intrepid explorer persists, sending back whispers from the frontiers of space, reminding us of our tiny place in the vast cosmic tapestry. As Voyager 2 sails into the vast expanse of space, it leaves us with more questions than answers. The universe, in all its grandeur, is filled with mysteries just waiting to be unraveled. And if tales of exploration and cosmic enigmas captivate you, you're in the right place. If you're intrigued by the unexplained and the mysterious, show your support by giving this video a thumbs up. Drop your thoughts and theories in the comments below. We'd love to hear from fellow mystery enthusiasts. And if you haven't already, hit that subscribe button to dive deeper into the enigmas of our world with us. Remember, every click brings us one step closer to unlocking the unknown. Stay curious and join our community of mystery seekers.